Hi, welcome back to our honors geometry videos. Here, let's talk about some altitudes and medians. So just as a review, we've got angle bisectors and perpendicular bisectors as our first two kinds of triangle segments. So points on the angle bisectors, if you cut an angle in half, are equidistant to the sides. And similarly, perpendicular bisectors cut a side in half and are equidistant to the vertices, or the angles. So I would encourage you to do a quick check just to see if you can identify whether these are perpendicular or angle bisectors. And then pause the video, try it, unpause to check your work. So here we've got a perpendicular bisector. I can tell because it is equidistant to the vertices, or the corners. Here I have an angle bisector. Because it is equidistant to the sides from where the angle bisector is. Anywhere on the angle bisector is equidistant to the sides. The third one is going to be an angle bisector. We are also shown two congruent angles right there. And then we've got a perpendicular bisector for the next one. And then another perpendicular bisector. And then our final one is an angle bisector. All right, now word problems. We need to identify what we want to be equidistant from. So if you're trying to have a picnic and you want to be equidistant or equal distance from the sides of a triangle, you need to do an angle bisector and find the incenter. And if you want to be equal distances away from three corners or three vertices, you would need to do a perpendicular bisector, because the circumcenter is going to be equidistant to the vertices. All right, now let's talk medians and altitudes. Medians are segments drawn from a vertex to the midpoint of the opposite side. And the centroid is where the medians intersect. So what does this look like? If the medians intersect at the centroid, then it's going to break up the median into two parts, into a longer part of the median and a shorter part of the median. So let's draw a median approximately to the center. Let's say that's the center. If I draw my medians, I'm going to get a centroid. This centroid is going to break up my segment into two parts, where the longer part is going to be 2/3 of the total, and this is going to be 1/3 of the total length of the median. So a couple things to note about our medians. The longer part is from the vertex to the centroid. So that's the longer part, and that is 2 times the shorter part length. So for example, if I had a segment, let's call this A, B. If I had a segment where this was 10 units long, the shorter part would be half of that, 5 units long. Or if this was 30, the shorter part would be half of that, or 15. Conversely, I could say take the short part and double it. So if the short part was 7, the longer part would be 14. Or if the shorter part were 22, the longer part would be 44. But what do I do if I don't know either part? Let's say AB is 60. If AB is 60, I need to know what is 1/3 of 60 for the shorter part and what is 2/3 of 60 for the longer part. So 60 divided by 3 is 20. That's 1/3. 2/3 of 60 is 40. And this relationship we talked about still holds, where the shorter part is half the length of the longer part. So let's look at an example together here. We are given that PQR is our triangle. NQ, where's NQ? Here's NQ. NQ is 6. So I need to figure out if NQ is 6, I can find out what is 2/3 of NQ and what is 1/3 of NQ. It doesn't matter which one you do. I usually like to go with 1/3 of a segment, just because it's easier for my brain to work with 1/3 or dividing by 3. So the shorter part is going to be 2. If I double that to get 2/3, I'll get 4 for the longer part. And the longer part is always from the vertex to the centroid. So let's check just to make sure. I have 2 plus 4 equals 6. That works. And the shorter part is 1/3 of the 1/3 of the total, or the shorter part is half of the longer part. So that works. All right, let's change gears to look at another segment, RK. RK is 3. RK is 3. Well, if RK is 3, that's from the vertex to the centroid. That is the longer part of the segment. So that's twice the length of LK. So 3 is twice the length of LK. And if I divide by 2, I get 1.5. So let's check our work just to be sure. If I were to add up 3 and 1.5, RL would be 4.5. 1/3 of 4.5 is going to be 1.5, the shorter part. That works out. And 2/3 of 4.5 is going to be 3, which was RK. So that works out as well. And our last one here, let's do this in purple. I'm given that PK is 4. PK is 4. That's the longer part from the vertex to the centroid. So the shorter part should be half of that. That should be 2 as well. Just like NQ is 6, broken up into 2 and 4. PM is 6, also broken up into 2 and 4. So then I can start to label these. K to Q we said was 4 in orange. K to M we said was 2, that was in pink. L to K we said was 1.5 in blue. L to R, or RL, was 4.5. If you look on the right side of our triangle. N to K, we said was 2. And P to M, if I add up in purple, 4 plus 2, I'm going to get 6. Now, one more thing to note. In a centroid problem, I could also give you side lengths. Like maybe this is, I don't know, that wouldn't be 4. Maybe it's 3.71. Well, this is bisecting. It's going to the midpoint, so that would go to 3.71 as well. Maybe this is 1.2. This would be 1.2. And maybe this is 4.6, and this could be 4.6. But what's important there is that the sides are being bisected by these midpoints as well. So something else to think about as we go through these problems.